So today we are going to be talking about projectiles, both horizontal and non-horizontal. Here is a really cool fact. If a gun were fired horizontally and at the same time a bullet is dropped and the bullet is exactly the same size, same model, everything. If it was dropped from the same height, they both would hit the ground at the same time. The question is why? We look at it and we know that the vertical motion can be viewed as a separate entity from the horizontal motion. Vertically, and that is in this direction here, both bullets have zero initial velocity. It's starting from rest and accelerates downwards at a 9.8 meters per second squared. The time to fall would be the same distance for either of these, so therefore they would be the same. Imagine that you were kicking a dog horizontally off the cliff. So horizontally, it would go this direction with an initial velocity of v sub h, and the h stands for horizontal. Assuming that there is no air resistance, so negligible just means very little, enough to just ignore, he falls in a path of a parabola. So notice that he kind of goes down in this curve, okay, until, of course, he splats. Why is this? Let's consider his motion to be the sum of his horizontal motion and his vertical motion. We can treat these separately. And notice here that v sub h is the horizontal velocity, and then v sub v is the vertical velocity. Sometimes you might also see vx and vy. Just be consistent. It doesn't really matter which subs that you use as long as it makes sense and you're consistent. Let's begin by taking some T-notes. A projectile is any object that is projected or thrown. This could be used by hand or by some machine. It is under the influence of only gravity. We disregard air resistance. We ignore it. One distinct feature of projectiles is that there is vertical motion and horizontal motion occurring at the same time. Below in this diagram, you see the cannonball being projected over the cliff some height above the ground. The path of the cannonball is here, and the ball is red. The cannonball can be seen to be covering distance both horizontally as well as vertically because it is falling down. We can actually find out the horizontal or vertical distances. We can find out its speed, as well as the time it takes for the object to travel its path, using the knowledge that we have learned from linear motion as well as from falling objects. Let's look at the vertical component of a projectile. We have already learned about falling objects. That is pretty much all the vertical component consists of. Here we have a dog on a cliff, some distance above the ground. And when this object falls, it will be falling under the force of gravity, which we calculate from using the equation F equals ma, where a, the acceleration, is due to gravity. Therefore, we can also say F equals mg. Now we know that acceleration by gravity is 9.81 meters per second. And we know this equation here, in order to find distance vertically, we would have d equals 1/2 gt squared. We can use this equation to solve for any of the vertical components, the vertical distance, or the time that it takes for the object to travel that distance. For horizontal motion, we assume that there is no air resistance. When an object is moving horizontally, as in this case with the dog, and remember he's getting kicked off, but we're only looking at the horizontal component. When the object is moving horizontally, there are no forces acting on it. This means that the dog moves with a constant speed. There is no acceleration. What we know of linear motion, we know that speed equals distance divided by time. If we wanted to know what distance the dog traveled horizontally, we just isolate distance, this variable here, and we get distance for the horizontal component equals the speed of the horizontal component times time. Let's make sure we have this information in our T-notes. So when we look at the vertical component of a projectile, we know that the acceleration by gravity is 9.81 meters per second squared. When we are trying to find the vertical distance, we use d equals 1/2 gt squared. Notice the diagram below and how the velocity of an object vertically is being affected by gravity. So here you see the arrow, the magnitude, the length of the arrow increases as the object goes further down in its path. And this is because, remember, the acceleration by gravity is affecting the speed as the object falls. For the horizontal component of a projectile, we are looking at the linear component only. The acceleration of gravity does not affect the horizontal motion, so the acceleration is 0. This makes the velocity constant. Look at the diagram below and you can see that the magnitude, or the arrow's length, is the same throughout the path of the object. We use the linear speed equation for v equals d divided by t in order to solve for velocity. Both of these equations can solve for different components of the same object falling. Because of this, we know that the time is the same for both the horizontal and the vertical. That's why we see time here in both equations. Because the time is the same for the projectile, we can use either the vertical or the horizontal equation to solve for the time it takes the object to travel. When you are solving projectile motion problems, there's a certain process that you need to do in order to know which equation to use to solve for what. The first step is to draw a diagram. This will help you to visualize what is happening in your situation. Step 2 is to list what you know that is in the vertical direction, which is also the y-axis, also known as v, denoted as v for vertical. List what we know in the horizontal direction, or the x-axis, and horizontal is also denoted as h. Identify what we need to solve, and then pick the equation and then solve the problem. Here's an example. A pool ball leaves a 0.60 meter high table with an initial horizontal velocity of 2.4 meters per second. Predict the time required for the pool ball to fall to the ground and the horizontal distance between the table's edge and the ball's landing location. Go ahead and stop the video and try to draw the diagram before starting the video back up. You should have drawn something that looks like this. Your picture does not have to be exact. You just need to be able to place the ball above some distance on the ground, showing that you know that the vertical height of the table is 0.60 meters and that the initial velocity for the horizontal motion is 2.4 meters per second. Step 2 and 3 is to list the known data for vertical and horizontal components. For the vertical component, we have these variables. However, we do not know the time. We know that the height of the table is 0.60 meters. We have the acceleration as being 9.81 meters per second squared, because remember, this is due to gravity. And we do not know the time. For the horizontal component, we do not know the distance that the ball traveled this direction. We do know the velocity, which was 2.4 meters per second, and we do not know the time. We need to identify what we need to solve. We were asked to find time, the time that it takes for the object to travel its path. We know that the time is going to be exactly the same for both the vertical and the horizontal components. It doesn't matter because it's the same object going through the air off of the table, so it's going to hit at the same time. But if you look at this horizontal component here with this equation, we don't know two things. We can't solve for one if we don't have the two others. Over here, we do have every single variable except for time. So we are going to choose this equation here. So what we want to do is we want to get time by itself, and that means we need to get this 1/2 g over here. In order to do that, we just put it onto the other side by multiplying by 2 and dividing by g. That leaves us t squared. So we're just going to take the square root of this and we will get this equation here. When you solve for t, you should get an answer of 0.34973 or 0.35 seconds, which is 2 sig figs. And if you look at our original information, we were given the uncertainty up to 2 significant figures. So our answer is 0.35 seconds for our time. The next step is to solve for the horizontal distance that the ball traveled. We know that that is going to be the linear motion equation. We're going to solve for d by isolating distance by moving time over. So you should get d equals v times t. When we plug everything in, you get an answer of 0.84 when you take into account sig figs. Here is another example. A soccer ball is kicked horizontally off a 22.0 meter high hill and lands a distance of 35.0 meters from the edge of the hill. Determine the initial horizontal velocity of the soccer ball. Go ahead and pause this video and use your TNOTES in order to map out each step of what you need to do in order to solve this problem. Then start the video back up to see how I do it. Step 1 is to draw a diagram. It can look something like this, as long as you show that the ball is somewhat above the ground and that your data points are placed in here. Here we have the vertical distance as being 22.0 meters and the horizontal distance is 35.0 meters. We are not given any other information. This is my diagram. Step 2 is to list the known data for your vertical and horizontal components. For vertical, we have this. For horizontal, we have this. Let's identify what we need to solve. We know that we want to solve for the horizontal velocity. However, notice that we do not know 2 of the 3 variables, so we cannot use this yet. What we do know, however, is that the time is exactly the same for both the vertical and the horizontal components. And looking at the data that we know for the vertical component, we can solve for time and then use this time over here in order to solve for the horizontal velocity. So let's pick the equation, obviously it's going to be this one, and solve the problem. This is the equation for the vertical component. Let's solve for time. And remember that is the square root of 2d divided by g. When we plug everything in, we get a time of 2.12 seconds. And that is 3 significant figures. Now we can solve for the horizontal velocity, which using this equation, all you have to do is plug in all the information that you have and we get an answer of 16.5 meters per second. All right, we've reached the end of our TNOTES. Have a wonderful day and see you in class.